Right now, there's a sensor in your car, no bigger than your finger, that could be silently killing your engine power, guzzling your gas, and shortening your engine's life. And it's doing all of this without ever triggering a single warning light on your dashboard. That's what makes this so terrifying. Dealerships and independent shops across America see the same nightmare over and over again. Spark plugs get replaced, ignition coils are swapped out, fuel pumps get blamed, thousands of dollars are wasted on parts and labor, and the problem doesn't go away until someone finally cleans a sensor that almost nobody ever thinks to touch. And no, it's not the one most people think it is. The average American now spends over $800 a year on car repairs. The average vehicle on U.S. roads is 12 and a half years old. As these cars age, sensors get dirtier, signals get weaker, and engines silently suffer, while their owners keep pouring money into the wrong repairs at shop after shop. Today, we're going to break down the most problematic engine sensors, one by one, starting from the commonly ignored all the way to the one that causes more failures than any other sensor in your vehicle. That sensor, the one almost nobody cleans and that can completely transform how your engine performs in just minutes, will only be revealed at the very end. Stick with me through this entire video. You genuinely do not want to miss what's coming. All right, let's get into it. Number 8, the oxygen sensor, also known as the lambda sensor. Oxygen sensors in your exhaust system are the engine computer's eyes for monitoring combustion efficiency in real time. They constantly fine-tune the air-fuel mixture, thousands of times per minute. Most U.S. vehicles use zirconia oxygen sensors with a ceramic element heated to over 570 degrees Fahrenheit that generates voltage based on the oxygen difference between exhaust gases and outside air. At the ideal ratio, 14.7 parts air to 1 part gasoline, the sensor outputs approximately 0.45 volts. Lean mixture? Voltage drops, signaling the ECU to add fuel. Rich mixture? Voltage rises, and the ECU pulls back. This constant feedback loop keeps combustion balanced. Over time, these sensors become contaminated by lead, silicone, or phosphorus deposits, often caused by low-quality fuel or engine oil burning past worn piston rings or valve seals. These contaminants chemically poison the ceramic element, slowing response time dramatically. The sensor still technically works, but sluggishly, sending delayed signals the ECU can't properly interpret. Your engine oscillates between rich and lean mixtures. Fuel consumption skyrockets, you notice real power loss, and you're almost guaranteed to fail emissions. According to CarMD's Vehicle Health Index, replacing oxygen sensors is the second most common check engine light repair in America, averaging $254 per repair. But in documented tests, cleaning contaminated O2 sensors restored proper readings in 70% of cases. That's hundreds of dollars saved by cleaning before jumping to replacement. And most people have no idea. But there's a sensor that gets even dirtier without anyone ever noticing. Number 7, the intake air temperature sensor. This tiny component is usually threaded into the intake manifold or tucked inside the air intake duct. Most drivers go their entire vehicle ownership without ever knowing it exists. But what it does is critical. It measures how hot or cold the air entering your engine is. Cold air is denser and carries more oxygen per unit of volume. Hot air is thinner with less oxygen. The ECU uses this sensor's reading to fine-tune how much fuel gets injected on every combustion cycle. When this sensor gets coated with oil mist, sticky dust, or residue from oiled aftermarket air filters, it can no longer accurately read the true temperature of the incoming airflow. The result is an engine running slightly rich or lean all the time, causing subtle but constant power loss, worsening fuel consumption, And in hot climates like Arizona or Texas during summer, even light engine detonation that slowly damages pistons. Technicians find that careful cleaning with electronic contact cleaner, without touching the sensitive element, restores sensor response almost immediately. But there's another temperature sensor controlling something even more critical. Number 6. The engine coolant temperature sensor. One of the most influential sensors in the entire engine management system, even though it's rarely the first thing anyone suspects. It tells the ECU how cold or hot the engine is, and the computer bases a massive number of decisions on this single input. During cold starts, the ECU enriches the fuel mixture, raises idle speed, and adjusts ignition timing based on coolant temperature. As the engine warms, those strategies gradually fade. But when corrosion, scale, or sludge from neglected coolant coats this sensor, it starts feeding garbage data. The ECU might dump extra fuel thinking the engine is cold when it's fully warm, or it starves the engine during an actual cold start, causing rough idle and hard starts on winter mornings. Excessive fuel consumption, rough idle, hard cold starts, cooling fans running at the wrong time, and long-term engine wear. All from a sensor costing less than $20. Many engines with seemingly complex drivability issues are completely restored after replacing this one cheap part. That's the kind of fix every American driver needs to know about, and yet almost nobody does. Now let's talk about the sensor that makes your transmission lose its mind. Number 5. The vehicle speed sensor. When your speedometer needle bounces around, your transmission starts making bizarre shift decisions, or your cruise control randomly shuts itself off on the highway. The silent culprit is often the vehicle speed sensor. Mounted on the transmission housing or the differential, it generates electrical pulses proportional to wheel speed or transmission output shaft rotation. The ECU uses this data for everything: shift timing, fuel cut during deceleration, cruise control engagement, and traction logic. Given its exposed mounting location, oil, road grime, and metallic debris contaminate it constantly. The computer might believe you're completely stopped while you're actually rolling at 65 on the interstate. Technicians frequently find that cleaning the magnetic tip, removing stuck metal particles, and flushing the connector completely eliminates erratic shifting that many drivers mistake for serious transmission failure. We're talking about a 10-minute cleaning versus a potential $2,000 transmission rebuild. Let that sink in for a moment. Number 4. The knock sensor. Bolted directly into the engine block, this sensor is essentially a high-precision microphone listening to every combustion event in your cylinders. It detects specific vibration frequencies caused by detonation, and when knock is detected, the ECU reacts within milliseconds, pulling timing and enriching the mixture to protect the engine from internal damage. When dirt, corrosion, or baked-on oil reduces this sensor's sensitivity, two dangerous outcomes follow. Either real detonation goes completely undetected, pushing the engine towards serious damage, or false knock signals force the ECU to constantly retard timing, robbing your engine of power and making the car feel heavy, sluggish, and unresponsive. Cleaning the mounting surface and reinstalling at factory-specified torque often completely transforms engines that owners thought were finished. 15 minutes with a rag and some contact cleaner. That's truly all it takes. Number 3, the throttle position sensor. The TPS is a precision potentiometer mounted on the throttle shaft, telling the ECU exactly how much throttle you're requesting at every moment. Inside, a contact slides along a circular resistive track, producing around half a volt when closed, and 4.5 volts at wide open throttle. The ECU uses this to decide whether to prioritize fuel economy during gentle cruising or deliver maximum power when you floor it. When the track wears or gets contaminated, dead spots develop, almost always at the positions you use most. Steady highway cruising around 65 to 70 miles per hour, stop-and-go traffic. From the driver's seat, this feels like jerky acceleration, sudden hesitation, brief power cuts, or even complete engine shutdown. Many drivers spend hundreds of dollars chasing fuel system or ignition problems that are actually caused by a worn TPS, something a technician can diagnose in minutes with a scan tool. Now we're getting into sensors that can stop your engine dead. Number 2, the crankshaft and camshaft position sensors. Without the crankshaft position sensor, a modern engine is literally blind. Mounted near the flywheel, it generates perfectly timed electrical pulses as the crankshaft teeth pass its magnetic tip. The ECU uses these pulses to know exactly where every piston is and precisely when to fire spark and inject fuel. When metallic debris, burnt oil residue, or general grime contaminates this sensor, the signal becomes distorted. The engine may randomly shut off when hot, crank abnormally long before starting, or lose spark for fractions of a second at highway speed. In US repair shops, it's extremely common to see engines with apparent ignition or fuel pump problems fully recover after nothing more than cleaning the sensor tip. No new parts, $0 spent. The camshaft sensor works alongside it, identifying each cylinder's exact cycle phase for sequential injection and variable valve timing. When oil sludge degrades its signal, the ECU drops into degraded batch injection mode, causing unstable idle, longer cold starts, and hesitation between 2,000 and 3,000 RPM that gets wrongly blamed on ignition coils or fuel injectors. 2 sensors, both critical, both almost never cleaned, both capable of generating hundreds of dollars in completely needless repairs. But before I reveal number 1, there's something that mechanics say causes more phantom failures than any individual sensor combined. Sensor connectors and wiring harnesses. The invisible killer. In countless diagnostics, hundreds of dollars get spent replacing sensors that appear defective, when the real culprit is corroded connectors and degraded wiring. Every sensor depends on 3 things: correct power supply, solid ground, and a clean signal path back to the ECU. But across millions of aging American vehicles, vibration, moisture, engine heat, and road impacts slowly destroy these connections over the years. Green corrosion forms inside plugs. Wires break internally under perfectly intact insulation. Grounds loosen with every pothole. Experienced technicians always wiggle the harness first, and the fault appears and disappears right before their eyes. A thorough cleaning with dielectric grease and properly securing the harness eliminates electronic ghost failures entirely. That's why the best mechanics always check wiring before condemning sensors. The problem is almost never the component itself. It's the path carrying its information. And now, the moment you've been waiting for. Number 1, the sensor that fails more than any other, that almost nobody cleans, and that can completely change how your engine runs in just minutes. The mass airflow sensor. This is the big one. The MAF sensor is the single most critical and most neglected component in modern fuel-injected engines. Its job is to measure with extreme precision every single gram of air entering your engine. And over 9,000 liters of air flow through for every liter of fuel burned. That's the staggering volume this tiny sensor must accurately measure every second you're behind the wheel. Most MAF sensors in US vehicles use a hot wire design featuring an ultra-thin platinum wire, roughly the thickness of a human hair. This wire is electrically heated to a constant temperature. As intake air flows across it, the air cools the wire in direct proportion to airflow speed. The ECU measures the electrical current required to keep that wire stable and translates that value into air mass data, updated in milliseconds. It's a beautifully precise system. When the wire is clean, here's where everything falls apart. Over time, Microscopic dust particles, oil vapor from aftermarket oiled air filters, and general environmental contaminants coat that impossibly delicate wire. Once contaminated, its thermal behavior changes. The data being sent to the ECU becomes inaccurate. Your engine's computer now believes more or less air is entering than what's actually happening, and it responds by delivering the wrong amount of fuel. Every combustion cycle, mile after mile, day after day. The symptoms are maddening because they mimic a dozen other expensive problems: power loss during hard acceleration, fuel economy tanking with no obvious explanation, unstable idle that comes and goes like a ghost, and in severe cases, the engine stalling at red lights or when you pull into a parking spot. And here's the worst part: a dirty MAF frequently doesn't trigger a check engine light. It just sits there, silently feeding false data to your engine's brain, making everything run worse while you keep paying more at the pump and have absolutely no idea why. Now here's the stat that should stop every car owner dead in their tracks. Diagnostic data from US repair shops shows that nearly 40% of vehicles with rich or lean mixture trouble codes have dirty MAF sensors, not failed ones. Dirty. They don't need a $300 replacement, they need a $10 cleaning. According to CarMD, replacing a MAF sensor is the fourth most common check engine light repair in America, costing an average of $323. BMW, Mercedes, and Audi owners face bills pushing well past $500. But a can of dedicated MAF sensor cleaner, $8 to $10 at any auto parts store. The entire cleaning process takes under 15 minutes in your driveway, $10 versus $500. You do the math. The savings are staggering. A dirty oxygen sensor can slash fuel economy by up to 40%, but a dirty MAF is more dangerous because of its stealth. No warning light, no dramatic symptom, just a slow, invisible bleed of performance and money that compounds over months and years. Drivers who've cleaned their MAF sensors report immediate gains of up to 6 miles per gallon, right after cleaning. Fleet operators like FedEx perform sensor cleaning as preventive maintenance every 30 to 40,000 miles, cleaning first, testing, and saving thousands across their fleets. Studies on high-mileage vehicles showed that cleaning key sensors delivered 12% better fuel economy, 9% faster throttle response, and 16% less idle fluctuation. So here's your action plan. Every 30,000 miles, or at least once a year, pop the hood, unclip the MAF sensor, and clean it with dedicated MAF cleaner spray. Never use carb cleaner, brake cleaner, or throttle body cleaner. Those chemicals will permanently destroy the platinum wire. Never physically touch the wire with your fingers, a brush, or a cloth. Just spray it generously. Let it air dry completely and reinstall. That's the whole process. It takes less time than making a cup of coffee, and it could be the difference between a smooth-running engine and thousands of dollars wasted chasing a problem that was never actually there. Now, before you click away, drop a comment and tell me, have you ever cleaned your MAF sensor? Yes, no, or be honest. Did you not even know this sensor existed before watching this video? I'm willing to bet most of you had absolutely no idea. And that's exactly why this video needed to exist. If this opened your eyes, smash that like button so the algorithm pushes this out to more drivers who are wasting money right now on repairs they don't need. Share this with anyone you know who complains about bad gas mileage or a sluggish engine. They might just need a $10 can of spray in 15 minutes. And if you haven't already, hit that subscribe button and turn on the notification bell so you never miss another video that could save you hundreds or even thousands of dollars on your car. I'll see you in the next one. Stay smart out there.